Hi, my name is Dan Friesen. I just one of these guys who likes to fool around in the shop, and I just made myself a spot welder using a microwave oven for some of the components. So if any of you are interested in building a spot welder, the basics of it are easy to do. Some of the things surrounding it, well, it depends upon how fussy you are, what you want to do with it. But this one is a serious spot welder. It works very well, I have to say. My first one didn't work that well, but I'll go through that. The first part, the main part of the spot welder is this here, which is the transformer, which you can get from your microwave oven. I pointed to mine in the kitchen there. This is the cover of the one I got it from. It's just an ordinary, get a large one. So you have a large enough. That one was a medium size. That was fine. Some of you may know that your transformer you can get from one of those and rewind it in order to suit this application. So I'll go through that briefly for you. There are other sites that go through it as well. Although mine has a little bit of a twist on it. First of all, there is your primary winding. Let's see, maybe this side you can see it better. Okay. This is your primary winding there. Your 120 volts goes through there. And then your secondary winding, which in a microwave oven steps up the voltage from your 120 volts to about 2000, and then they put it through a half-wave rectifier, I think it's called, and eventually it comes out pulsing your magnetron. Don't worry about these names if you're not familiar, but it's a magnetron that feeds the microwaves into the oven, pulses it at about 5000 volts. But that's what you don't need. You don't need that secondary. Okay, so you want to cut the secondary off. Now, here, let's show you this side. This is where I cut the secondary off, right here. Okay, so you just slice this down there. You can slice it. I have the privilege of having an electric hacksaw, but you can just take an ordinary hacksaw and slice through that. It's not that difficult because it's only aluminum generally, although some are wound with copper, but that's okay. So you can take a chisel or a hacksaw and slice that end off, and this is what I took out of mine. Okay, so slice that off and then pound that through. Okay, and then you'll end up with an empty area in here, and then you might notice there's a couple of metal pieces in there as well that you don't really need for this, and you might need the room for the winding, so you can pound those two little metal pieces out as well. I forget what they're called, shunts I believe they're called. They have to do with the capacitor that they use, charging the capacitor, and that's not necessary. Oh, there's also another winding in there. It's just a couple of, just a few turns, and it feeds the heater for the magnetron. That's not needed as well, so you can take that out. So you're just left with the primary winding and the core. Okay? Now, if you've seen any of the videos online, you have a variety of things that are of sizes of wire that people have put on this. In my experience, what I did was I used wire from a car battery. Okay, that's number 2 wire. I don't know if you're familiar with the wire sizes. You know that in house wiring you have regular 14, number 14 for your 15 amps. Say if you want 20 amp, you'll go to number 12, And then as the numbers get lower, the wires get higher, or the size of the wires get higher. This one is a number 2. Number 1 would be thicker. However, using this wire, since you have so many amps going through there, this is what happened. Okay? It gets hot after just a few welds, and you know, if you have the proper number of amps going through there, you're going to it's going to get wire like this very, very hot. So you don't want that. I was lucky enough to happen upon this stuff. Now again, with wire sizes, it goes all the way down to 1, and then where do they go from that? Well, you may know it goes to 1/0, and then 2/0, 3/0, and 4/0. 1 0, 2 0, 3 zeros, and 4 0. This is number 40. It has a 1/2 inch diameter braided copper. That's a heck of a lot. And I really needed to go to something a lot thicker than this in order for the machine to be practical at all. I didn't mention that although this is used to step it up to 5,000 volts, when you're finished, you want to have stepped the voltage down, in my case, to 2 volts. I put 2 turns, that's all I could get on here, and it's perfect. With the car wire, I put 3 turns, I got 3 volts. It was 3.1 volts. This is pretty well exactly 2 volts with 2 turns. Hey, if you wanted to jumpstart your car, you could put 12 turns on it, and you can get approximately 12 volts. It just works out that way. So anyway, this particular machine is running at, and I want to be careful here, but I think it's close to 1,000 amps at times, because I have tripped this breaker. Actually, I tripped the breaker when I put aluminum in between it just to see. But aluminum is a very good conductor. It's a little more than half as conductive as copper, but it's still a very good conductor, and it tripped the switch, and that's 20 amps. So I had an awful lot of current running through there. So you're going to get, with this setup, you're going to get 1,000 amps of current at times. Now, that's anyway. Just going to kind of circulate this around a bit so you can see some of the details. Now, I used a fair number of things from the microwave oven. First of all, of course, is the transformer. And some videos have used, in order to turn the 110 volt on, in order to turn the primary on, they've used an electronic circuit because it draws a fair number of amps. This one will draw up to 20 amps. That's quite a bit. So they've used like a solenoid and stuff, but that a bit fussy for me. And in the microwave itself, there were 3 micro switches which were rated at 15 amps. So that's what I've been using. I took a hockey puck and routed out a square hole in the bottom just for a tight fit for the micro switch. I put a little piece of plastic on top here to activate it. Okay, so yeah, the electronics are not necessary. Just use that 15 amp micro switch, and that works fine. The fan I put on because it was getting so hot. Actually, the way it's working now, it's not getting very hot here at all. So really, the fan is not needed. So you can cut that point. However, the weak spot here now is the aluminum. This is 3/4 by 3/4 aluminum. This is more likely to get hot than the copper because this has a certain amount of resistance compared to copper. And but it'll still, I mean, you can work for 10 minutes without worrying about that too much. Here are contacts that I bought. They are for spot welders. So they have a screw section, so I threaded these in there and screwed those in, and that works great. Now how I activate the jaws is with a pedal that I made. Now I get a little fussy, and some of you won't have the shop available to you to do this sort of thing, you know, so you can do it differently. The first one I made, I tried just going like that, and you know, so the electricity was on, and when I went like that, it would spot weld. But what happens is, as it goes down, here I'll put this a little closer. As it goes down, there's a little tiny bit of an arc, not much, but just enough to make sparks, because it's only 2 volts. Remember. But once it's very close to touching, you have those sparks, because that's a very tiny space. And then when you release it, the weld is still hot, so it's likely to come undone because it hasn't had time to cool for that split second that it needs. So really, what you need for a cycle is to close it on it, then turn it on for a second, or until it glows red in between there, then turn it off, okay? In this case, the micro switch, just release the micro switch, and leave it for a split second before releasing it. That gives it time to cool and gives you a strong weld. Okay, now I was explaining the pedal with mine. I have it this configuration here with a bicycle, you can see, with a bicycle cable that goes in. And what I've put on here, okay, is a roller, so that it just makes a nice smooth operation. I mean, you don't have to be fussy like I am if you don't want to be. Pedal, bicycle cable to here. All right, spring in between. Oh, there's a couple of rollers in there, but make it the way you like it. But make it sturdy. If you make a pedal at all, you might want to do something simpler. But I find it very, very handy. Spring in between here. If you put a spring in between here, of course you want to put some insulation, because otherwise you'll short this out. Thick wire. We've got these wire ends here. Those were expensive. That was a good part of $20 just for 2 of those. Maybe I shopped at the wrong place, but anyway, most of the rest of the stuff was just lying around my shop. Okay, so this is a serious machine. Not only does it do all this, I don't know, this 20 gauge or so, this sort of welding for this light stuff, which a lot of spot welders are for. You know, you're making, I don't know, for me, I made a bunch of things to fur out some electrical boxes in this house that I put the electrical boxes 1/2 inch out like normal for gyprock, but then I decided to use clay and sand and straw for the inside, and it came to more like 1 inch. So these are things to fur that out. So anyway, lots of practical uses if you like playing around in the shop. I was very anyway, I'll show it to you. Operating. Okay, so we'll turn the switch on. Now you can see, I don't know if you can see that, it glows red hot there, and you try to tear that apart and it just doesn't come, okay? So I was really happy with it once I put the heavy windings on it, and it's just a really fantastic machine. Not bragging, of course, but what I'm saying is it works, eh? And now this, for instance, this is pretty darn thick stuff. 3/30 each, and when I welded that together, it's a total of 3/8 of an inch, and that's really strong. I haven't been able to tear that apart. Now what I'm going to do here is I'm going to try put this really up close here. Try not to burn my iPhone here. At least it has that protective covering. I'm going to put a couple of these. Now you see how thick this is. This is 1/8 of an inch each. I'm going to try doing that. Now I tried it earlier in the middle, and it worked for a bit, and then it broke apart. So I'm going to try it with a little bit less surface area, okay, because that's a lot of metal to absorb. And we'll just turn that on and see if that welds. Now this is longer than you would normally weld something, but for this thick stuff you need it. Now my breaker just switched off, okay, because normally you don't leave it on that long, but this is really thick stuff for illustrations purposes, and I'm not going to grab it with my fingers. Let's see how this did. I'm curious myself. Okay. So you can see that's a little warm. Grab this end. Okay. So this is heavy stuff. Is this going to break apart? It might. You know, that's not breaking apart. Wish I had pliers here. Well, that's thick metal. That's amazing. I'm really happy with that. So that's a 1/4 inch of metal that this beast has just spot welded. Okay. So anyway, that's about it. I'll be open to any questions or comments. I'd love to hear your comments, and if you have any questions, I'll try to answer them. Just trying to think if I've left out anything. No? Okay, bye for now. I hope this was useful to you.